So like hearing Ian talk was really a sort of great moment for me sitting back there, just kind of thinking about all the things we've been thinking about for WebRTC since we created it, now actually becoming real. You know, the idea that somebody can create these applications and services all in their browser, you know, just using APIs someone else is providing, it's a huge step forward. You know, the sort of financial application he was showing at the end, that's exactly the kind of thing we want to see happen with WebRTC. But let's tell you a little bit about ourselves. So can't
find the wire here. I'll let you start.
Yeah, let's try that one. Okay, so I'm Justin Uberti, tech lead for WebRTC at Google. And with me today, all the way from Stockholm, Sweden, Serge LaChapelle, our product manager. And we've worked together for a while. You know, we've worked together on some previous projects at Google, Google Video Chat. You can see Serge and I there in the screenshot, plus our work on Google Hangouts. And we're, you know, two of the co-founders of WebRTC. And when we set out to bring out WebRTC to the world, we had a bunch of ideas that we really wanted to sort of focus on. And let's take a look back at kind of what this vision was. Well, the original vision was we want to take the communications industry and bring it and mesh it with the web. Take the communications industry, a $1 trillion industry, and get it moving at web speed. Instead of releasing things on multi-year ship cycles, we can do things on multi-week product cycles. And this is like really, really important for like allowing startups to do things quickly, to actually, you know, take the power of the web and use that to deploy applications just by going to a web page, just by getting a set of APIs from a service provider, to do all these kind of things like in a weekend. It's really incredible what we've been able to accomplish. The second point was to be able to put a state-of-the-art communications engine in every web browser. And this is the kind of thing where if this stuff is in the browser, people don't need to spend their time on the details of sending packets and peer-to-peer. This stuff is all done for you. You can spend the time working on the unique things about your application, which allows communication to be a feature of other types of applications. And just the stuff that Ian showed, I think, gives a little taste of that. The idea that communication can be integrated into financial applications, collaboration applications, customer service, telemedicine. There's so many opportunities that WebRTC is uniquely suited for. And lastly, we want to make sure that WebRTC was not just about Google. We wanted this to be a cross-industry effort to establish a common way for devices to communicate in real time. Really, you know, a next-generation phone network. So, you know, it's been a year since I stood on stage at the first WebRTC World, and now I'm here, and there's a lot more of you. So, how did things go over the past year? Well, on the browser side, you know, we were shipping Chrome since Chrome 23 with WebRTC support, but we've been joined now by Firefox, who's been shipping since Firefox 22, and Opera, which is now shifted over to the WebKit and Chromium stack, is now shipping as part of Opera since Opera 18. And we think there's still a lot more to come here. We've also made sure we interoperate with the other implementations of WebRTC, so that when developers build their apps, they can be assured that this stuff is just going to work together. This is one of the benefits of the web platform. You have different people building stuff, but overall you have a huge network of devices, and it all just works together. And we're proud to announce, as of now, we have over 1.2 billion WebRTC-enabled endpoints out there, just in browsers. We think this number is going to continue to grow very rapidly as we get uptake across Android, Chrome for Android, and some of the other browser applications. But if you count the applications that are out there, they're outside the browser, mobile apps like Vonage's mobile voice app, we think the actual number of deployed WebRTC applications is probably over 2 billion. So this is compared to like an overall number of phones in the world of about 3 billion. So we're talking about some pretty big numbers, and we're catching up to the incumbents really, really fast. It's pretty exciting. So there's also, as a result of this, a booming WebRTC ecosystem. Over 250 companies that we're tracking, creating WebRTC software and services. And here are just some of the apps that have been created over the past year that we think are pretty interesting. This is one being created by Citrix. We just saw it the other day. Really fast, really slick, easy way to have multi-person video chat right in your browser. It works with Chrome, and it just works great. We tried it out, and we all had a fun time playing with it. But to see big players like Citrix start to get engaged with WebRTC and ship real apps, I think we're seeing a really important trend here. ShareFast, this is kind of a little guy, but they've done a really cool thing with the web data channels. Basically, a way you want to send a file, you just drag it to ShareFast. Somebody else can go to the same URL, download that file securely. It works fantastic. Peer-to-peer file transfer in your browser, only a few lines of code. We put on this thing, we call it a Chrome experiment. It's called CubeSlam, and it's a game where you can play Pong using a bunch of the technologies that we have on the web platform all together. We've got web audio for sound effects, WebGL for the graphics, and then WebRTC for the data channels for actually coordinating the gameplay, and of course video so you can see your opponent as you knock the ball into their screen. It's a lot of fun. If you haven't tried it out, I definitely recommend it, cubeslam.com. But this just shows how all the pieces come together to make WebRTC like a really integral part of a bunch of different types of applications. Now, outside the browser, we have some other things like Chromecast. The ability to take something on your PC and push it onto your TV. Like all sorts of people are watching content on their PCs, but to be able to do this on your TV without having to set up some sort of long cable or other sort of complicated setup, this is what Chromecast is all about. In this process of taking content on your PC, encoding it and sending it over to your TV, it's all done with WebRTC. It's one of the use cases that we might have thought of in the first case when we were thinking of what can we do with WebRTC. But this is exactly the kind of things where if you put this into the browser, all sorts of new things start to develop. And one other thing that I think is pretty interesting with new things starting to develop, this is something done by a company called InQuality Media, running on top of the V-Line platform. And they actually did an interview where someone was able to call into Sky News using WebRTC. And so they had this correspondent who was basically reporting from a studio, but the connection, instead of being done with an expensive satellite truck, was done with this setup. This is what they call the remote contribution terminal, and they have a reporter sort of be in the field with just like a MacBook, a webcam, and a microphone. The fact that you could now sort of have a news broadcast with just this much equipment, I think is pretty exciting. So in addition to that, here at Google, we've been cranking away on the actual feature set for WebRTC and Chrome. And so I won't go into all these things in detail, but these are just some of the major features we've added over the past year. And we feel like the implementation is getting pretty stable. We feel like the implementation is getting pretty complete. There's still some stuff to do, but we've been cranking away at a furious pace. And Chrome has really gotten a lot better and a lot more stable as a result, to the point that you can do some of these demos like I just demonstrated and Ian showed in the previous presentation. So the web platform, though, has been moving forward as well. We've been cranking away on WebRTC. A bunch of our friends, working on other parts of the HTML5 stack have been doing other things that help, interact with WebRTC in very cool and interesting ways. So Serge is going to show some of the cool things that, we've been working on with these other pieces of HTML5 over the past year.
All right. So let's see if we can switch to my computer, please. Ta-da. So for those of you who are just getting going with WebRTC, this is a simple.info. There's a lot of great little open source demos here. Page is asking me for access to my camera. Oops, this is a little media thing on my Mac. Here we go. And this simple app just gives me access to my camera and puts my video on a canvas on the web page. There's a source code here, simple info/get user media. If we work If we talk about other fun things, well, we've been talking about, a lot of people are talking about this codec debate. No one's proposed the ASCII codec. I think it's fast. You can see me, it's ones and zeros going across the wire. Well, if anyone wants to submit it to the ITF, I'll support you.
Yeah, I think it compresses really well if you use like zip or something like that.
Exactly. Other uses of WebRTC that aren't, that common. Here's a website called Shiny Demos. I'll just press allow here, and Shiny Demo is going to try to detect my face, and it has, and it's going to try to follow my face as I fly through a minefield. And here we go. Oops, I missed it already. All these things, they're quite simple, but again, this is all the web coming together, right? I'm doing face tracking in real time in JavaScript, and it's all wired together with simple JavaScript. How about we go to ShareFest and take a look at ShareFest. So now I'm going to go to a page that has, already, boom. That was fast. So Justin hosted a file. I connected to a URL on ShareFest. This file was sent to me over data channel to my hard disk. And here it is. Ta-da. And now we're both hosting this file. So any of you that want to go to this URL, you'll also get a nice space shuttle on your computer. So this is, ShareFest is great because it does peer-to-peer sharing, and it's very quick and quite robust, to see how it works here. We tried it over the Wi-Fi before backstage, and we were also impressed because we could barely read email, and yet we were getting these files through. Let's see what else I have here. My bookmarks. Let's see what other surprise. Another great use of WebRTC, well, the Get User Media API is also wired into Chrome to use web speech. And so the same web speech that powers Google.com that allows you to do web searches with your voice is wired on top of some of the same stack that we use for WebRTC. Hello, Chrome. How are you today, period. You are doing web speech API demonstration, comma, webbed feet. Nope, that it tripped. And we can go on and on and on like this. And let's switch it to, we can switch languages, and it does continuous speech recognition. And we've seen these cute services like Siri and the others that take one chunk of voice, processes it, sends you an answer. This is continuous. I can dictate and dictate and dictate and dictate. And I can make you laugh. So let's see what else. What other demos did we have here for all of you? Maybe you have the slide up.
Yeah.
Screen sharing. So this is a good one. Screen sharing is now part of WebRTC. That doesn't mean that any website out there can go ask you for a permission to share your screen. We see that both Chrome and Firefox, we see that as a potential security issue. What we do offer, as of it'll be in the browser in stable next year, but it's already in the dev and beta channels of Chrome. We offer developers the opportunity to create an extension that can be downloaded on the Chrome Web Store. This extension, when users install it, they'll accept the permission that says this web app or this extension will be able to do screen sharing. And so it looks a little bit like this. It's a simple example on HTML5 demos. Capture your screen. I get a pop-up saying, hey, this website wants to capture your screen. I'll hit yes, and I'm capturing a screen. And this is not rocket science, as someone mentioned, but it's pretty responsive, and this is something I can then send over the wire, either over data channels or different ways of transmitting this. And so this is going to be also important since screen share is an important use case. Now, sometime early next year, we're also going to have a picker. You'll be able to choose whether you want to share your whole desktop, you want to share a part of your screen or a window and so on. So keep an eye out for that as we're working hard on it.
It's coming to Chrome 33 stable.
Thank you. It's good to have you. Other things that you can do, for example, this is a demo of alpha channels. So this is something that we'd like to start exploring a little bit more. And an alpha channel is a depth signal. And so it allows you to remove the background from a video. So this is quite interesting. I don't think I can dance like that, but you can see like the movement and how it blends well with the background.
Yeah, you could have video that's received over WebRTC that's no longer confined to be in a rectangle anymore.
Correct. And we'll do some web audio stuff in a minute, so we'll go back to Justin's screen.
Okay, so between the browsers, the users, the apps, the features, I think WebRTC has made tremendous progress over 2013. And to the earlier point about creating this new sort of ecosystem, this new phone network, we have the actual CTO of the FCC, Henning Scholzren, basically says, WebRTC is turning voice into just another JavaScript application. And he was saying this about the end of the PSTN. And does anyone guess what's next? But we think WebRTC is in a prime place to be the future of how we communicate. So that's 2013. Looking forward to the next chapters for WebRTC. So here's what we think is going to happen. And we finished a lot of the implementation of 1.0. We think that on desktop, things are going to be super stable, and people are going to be shipping real production applications. Pretty much everybody who's doing a collaboration app is either working on or will be working on a WebRTC version of that app. And we know, I've talked to a number of the major players, in 2014 is the year where they're going to start shipping this code. We've also seen a number of signs that the remaining browsers that don't support WebRTC today are working on adopting WebRTC, whether it's check-ins in open source repositories or other things. There's no way to know for sure. We think it's very likely we're going to see some new WebRTC implementations in 2014. And on the standard side, a lot of the major open issues have been resolved. And this is clearing the path for the specs to get done, hopefully by the end of next year, which will then open up, the market for all these devices that want to be WebRTC compatible. Now, those are the things that are in flight. There's also new stuff coming. We have a bunch of work on new codecs, which I'm going to talk about in a second, and new areas of innovation for WebRTC. So on the codec side, probably everyone here is really familiar with the sort of stalemate that exists in the IETF around codecs. Different companies have different perspectives, but the one thing that we are seeing is that the startups that are really going after WebRTC aren't being slowed down by this at all. For them, the freedom to build their applications and deploy them the way they want to, without restrictions, is the most important thing, and that's why startups are strongly favoring VP8. With the overall WebRTC ecosystem being built around open standards and open source, we want to make sure that the entire platform remains open so they can have the maximum possible adoption. But on the codec side, we're not standing still. We have a lot of work on this new codec we call VP9. And here's just a little quick demo, comparing VP9 against H.264. And you can see that the data rate for the same visual quality is about half for VP9 compared to H.264. So you can get the same quality at half the bits, or twice the resolution, going from 720p to 1080p at the same bits, or in other improvements in quality. But VP9 is a substantial step forward, and especially if you think about mobile, especially if you think about constrained networks, being able to save bits and be more efficient is going to be a significant improvement. VB9 is also getting SVC. And SVC, scalable video coding, is the ability to do sort of hierarchical prediction so that you don't need to receive all the frames to be able to decode video. And this allows you to have servers or conference servers that strip out frames as necessary to make it fit your bandwidth or make it fit your CPU. And so Video Incorporated is donating some of their IP to WebRTC, like many other companies that have donated IP to WebRTC, and it's going to bring a number of benefits, especially for conferencing use cases. We'll have better packet loss resilience, because only things in the base layer will actually be required for actual decoding. We'll have better rate matching, so we can adapt streams to more bit rates. And we'll have faster stream switching, the ability, if you want to send stream A to someone and then switch to stream B, to do that without having to send a whole new interframe. There's a lot of exciting things that are going to happen here, and it's going to make the WebRTC technology stack really best of breed from top to bottom. So talking about other areas for innovation, there are a number of new use cases that people are trying to do with WebRTC that are not even like the things that are talked about in the spec documents and the spec use cases. As Ian said, people don't read the spec. They just want to get their stuff done. And these are the types of things that people are doing. A peer-to-peer content delivery solution, for sending like live events when you have millions of viewers. Instead of building all that bandwidth and fiber, do it over peer-to-peer. Gaming, the ability to take a game, do it in the web browser, and have that sort of Twitch stuff by sending the data commands peer-to-peer. Instead of having to have everything go through a server and have all the latency associated with WebSockets or TCP, you can now send game commands over the peer-to-peer stuff that we're building into the browser. We've also got stuff around people doing like virtual sort of musical collaboration using the Opus codec, which has like full band music support. People are able to collaborate and do like musical performances in real time. Other things like cloud video editing and real-time media delivery. For the case where you want to do a live event and you don't want to have the buffering associated with like HTTP, you could deliver actual like streaming content over WebRTC. And these are just some of the things that we know people are trying to do, and we want to make sure that we give them the tools to make that possible. But there's another thing that's happening in WebRTC, and this is mobile. And mobile is not unique to WebRTC. Overall, the entire industry is kind of being transformed into sort of a mobile-first approach to computing. And if you look at the trends in terms of consumption of internet services, mobile internet will take over desktop in 2014. And so that means basically anybody who's building something needs to be thinking about mobile right now. We also see that these mobile devices, which are previously kind of, didn't compare well to a desktop computer, are way less powerful. That gap is narrowing, and it's narrowing extremely fast. Basically, if I look back at my computer from 2008, my new Nexus 5 is now faster than that computer. Basically, the top-of-the-line iPhone or Android device is now as fast as the top-of-the-line MacBook was 3 years ago, or the top-of-the-line MacBook Pro was 4 years ago. And if you look at the slope on these curves, that gap is going to get smaller and smaller. So the things that are possible on desktop now, we should expect to be completely possible on mobile. Now, there's a bunch of challenges, batteries, power, heat, that we still have to deal with. But we're getting some of the components in hardware that will help with this. The new version of Android called KitKat has a version of the Media Codec API that's suited for real time. Previous versions of the Media Codec API were mainly meant for like, well, let's record a video and upload it to YouTube. But we now have the ability to do things, control bitrate on the fly, control interframe generation on the fly, all in the actual codec API, so that we can do live applications, and adjust that bitrate to do things we need for real time, on Android. And the Nexus 5, this phone, is shipping with a built-in hardware encoder and decoder for VP8. So we can do 720p 30 encode and decode without this thing breaking a sweat. And this is running Qualcomm 800, Snapdragon 800. But that's not the only chipset. There are many vendors shipping VP8 hardware codecs this year, and pretty much this will all be present in all the phones, except for a couple, next year. So the hardware codec thing is super important if you look past phones to things like wearables. Now you can imagine glass, a prime example where WebRTC could be useful. You're walking down the street, you can show what you're looking at, all sorts of interesting applications there, hands-free, telemedicine, this kind of stuff. And it's not about compute power in many cases, it's about battery or about heat. If you're generating a lot of heat in the CPU, there's just no place to sink this. So the ability to use things like hardware codecs to make sure that we can deliver amazing WebRTC experiences on these devices is really important. But WebRTC needs to adapt a little bit to work on these to work in these constrained scenarios. But the short answer here, we need to make sure WebRTC works amazingly on mobile in all these use cases. And with WebRTC 1.0 getting really stable on desktop, we're investing really deeply on mobile. We're going to make sure Chrome on Android works great. Use hardware where possible, polish up our audio pipelines to make sure we have no glitches, optimize our use of radios to conserve power. We're spending a lot of energy here. But we also know that Chrome for Android isn't the solution to all the cases. Turns out there's more than one mobile platform. And some of these things like wearables, they don't really have the same browser to speak of. And so we're providing fully supported Android and iOS SDKs to make sure that WebRTC can go off and hit all these mobile use cases as well. And you can download and start using this, peerconnection.java, as well as the same thing for Objective-C right now. We want to be able to deliver a consistent experience regardless of what platform you're on. So the one thing that's also very exciting is the way that we're seeing services emerge, where you don't have to forge your own steel. WebRTC puts all this technology in the client for you to use. But if you want to do recording, or you want to do some sort of turn service, there's still a lot of work to do in many cases. But fortunately, a bunch of people are stepping in to say, hey, look, just use our services in the cloud, and we'll do all this stuff for you. There's a company called PubNub, which is exhibiting here, which has a really interesting sort of two API method for sending and receiving messages asynchronously. WebRTC leaves signaling up to the application. This fills that gap perfectly. vLine has done a bunch of also exciting WebRTC services, and they take care of things like stun and turn to make sure firewall traversal for WebRTC is handled automatically for you. And then PeerCDN has created a whole sort of set of APIs around peer-to-peer content delivery. So I was really excited to see Ian show off his services around things like archiving. Things like recording are things that the WebRTC platform has been waiting for, and I'm glad to see TalkBox now provides that sort of functionality to developers.
We should remove the coming soon.
That's right. I thought about it, actually. But yeah, I think that this kind of thing where you can stitch things together from one solution provider in a browser, and then you just write your app around it, is going to be extremely powerful. We still think, though, it's too hard for people to create services, though. If you really know what you're doing, you're a big company, you can go off and take the WebRTC C++ code, compile it into your server, stand it up, replicate it through a bunch of Amazon, AWS data centers, get your hands really dirty. But it would be great to be able to create WebRTC services like archiving or conferencing, basically as easy as you create the actual web application. And so we think that it would be super powerful if you can write a Node.js module that knew about WebRTC. So if we kind of look forward, what we really want to do with the WebRTC API and platform is have a unification across browser, mobile, and server, where we have a single, powerful, flexible WebRTC API that can be used in all these cases. Whether you're using native code on the mobile, JavaScript code in the browser, or JavaScript in a Node.js or server context, the ability to write these applications using the same set of APIs, tools, concepts. And so we think as we look into 2014, this is really a next chapter for WebRTC to go after. Now, Google isn't going to do all of this by ourselves. And so we hope to have people start helping out with this as they create like the server modules and other sorts of things to make the overall WebRTC ecosystem that much more powerful.
All right, so we're going to go over to a demo. This is a company, a Swedish company that I met just a week or two ago. 4 guys, self-funded. There's not as much VC funding as here in the Valley. So these guys self-funded themselves, built an app that really shows the power of the web coming together. This web application called Soundtrap is built using a web programming language that Google introduced last week called Dart. This is all written in a language called Dart, compiled to JavaScript. It makes extensive use of web audio. It makes extensive use of our new capability to pump get user media data into web audio. It makes use of WebRTC. It makes use of WebSockets. 4 guys, all 4 of them guitarists. And so we'll demo this a little bit. So here, this is kind of a social app. So I log into Soundtrap with my Facebook account. I decide that I'm going to build a song. This is Serge's song number 2. And I have a series of instruments that are available. I can plug in a MIDI instrument. So I forgot to mention WebMIDI, another web platform. I can plug in a MIDI keyboard, a MIDI drum set, and let's see if am I getting audio from the mic here? Let's see. You know, so I got different organs, and this is all done in the browser. And I can add maybe another track here. I can add drums, different kinds of drums. Probably loading from Sweden, so it's a... Actually, I do think it's loaded from Sweden. So, thank you. Oh, wrong button. I got carried away. All right. So now, the idea here is that I can lay down a track. Let's say I've got a good drum beat. I can lay down a track, record it, upload it via WebSockets, and say, hey, here's a great drum track. Is there any guitarists out there that would like to add a guitar track to it? And so Justin can log into his Soundtrap account, see my little offer or my request for help, and then just play my drum track and add his guitar over it. So if we switch over to Justin, there's nothing secret here. He's got his guitar plugged in analog to his mic in to his MacBook. That's it. There's no amp, no pedals, no effects. What Justin can do is he can add a series of effects using web audio. And these effects will be applied to his guitar signal in real time. So you see, all run in JavaScript, right? No more guitars, no more guitar pedals, no more of all the trickery to get great sound, all done in JavaScript. So why don't you add another effect just to... And he can change the guitar track on top from a rock guitar to different kinds of guitars very, very easily. Now where it gets a little bit mind-blowing is that the people at Soundtrap, they didn't read the spec, they just took a look at Chrome and see how could we build a great music app using Chrome. And so then they said, hey, we should maybe add the ability to do a video call here. So I'm going to call Justin. This is probably a good place to have a really amazing echo, so I'm just going to mute myself. And so let's jam together. I'm going to ask for only the output from my computer to be played out on the speakers. Thank you. let's see if we can, do we get you through? Oh, I'm muted. Let's try now.
Ready?
So now they're using the high-quality Opus stereo codec to feed the audio over WebRTC into my browser, and all the effects are applied and everything on his side, fed into WebRTC. The other thing we can do is we can record these tracks, because obviously this is not as great audio quality. There's a little bit of delay. Things aren't as perfect when we're doing it live as if we're recording it all by ourselves asynchronously. So we can all record this and then upload it to the server using WebSockets and then do editing. And so tighten the drums, tune the guitar sounds a little bit, and so on. So basically, I'm no drummer, I'm not a musician. Probably one of the reasons I'm forcing my son to take piano lessons. So this is about all I can do, but Justin, he can rip a little bit. So we're not going to quit our day jobs. And again, this is the web platform coming together. When Justin and I sat down and started thinking about building WebRTC, we never thought this would happen. Like this, when I saw these four guys come in and say, "I would like to show you something we built," I actually got a bit scared because, whoa, this is not at all what we're testing. This is not what we're designing for. And yet, by making the modules open, by making it easy to access, and providing a lot of examples, they've been able to build this in a few months. 4 guys. So I encourage you to try it out, soundtrap.com. And yeah, that concludes this demo. There you go.
Don't read the spec.
Yes, don't read the spec. I guess that's it for our presentation. So we have a few minutes left. Ask us anything. Does anyone have any question that they have on their mind about what they've seen here or things we haven't presented, please? You're very interested in data channels, okay? Your question is by what time frame data channels will be in the browser? It's all there. It's all there in Chrome and in Firefox, and it's very interoperable.
Yeah.
Did you get? I couldn't hear. Sorry. You'll have to speak louder.
Yes.
Yeah. You can build mesh networks with data channels without having to have a server in the middle.
Yeah. The question was about the use of turn servers, but I think that it probably might be better to just have answer the question offline afterwards. It's like a complicated question.
You're going to have to speak really loud.
Excellent question.
Wow. We get that one every time. Justin and I are part of the Chrome team. We work very closely with the Hangouts team. They use a bunch of our stack. They've recently moved over to VPA technology. They use a bunch of our audio stack and so on. Hangouts is a huge product, and they've announced recently their intent to transition to WebRTC. And I invite you to ask the question to them as to what their pace is, but they've made a public statement saying we're moving over to WebRTC.
Yeah, remember when I said that multiple major players are planning on shipping apps in 2014?
That's one of them.
How about Microsoft? Microsoft has a bunch of RTC apps that are fairly commonly used, and we think that they would be a great fit for the WebRTC platform as well. And we think that they probably would want to have it in their own browser too. So like I said, there's nothing that's you can take to the bank, but I think there's going to be some other WebRTC implementations in 2014.
Yes. Because screen scraping, people do their banking online, their emails are online. So there's so many things in the browser.
The simple answer is that the attacker controls both the content and the capture. So because of the way the web works, if somebody loads a web page and iframes in Gmail, Gmail will open in that iframe. So an attacking page that wanted to read all your Gmail or access your Bank of America can load that site in an iframe and then also scrape it using the screen scraping API. And they only need to get one frame, to get some of the information they might be after. So we think that the web is a bit of a thorny area here in terms of we don't want to have this being invoked by sites that might be malicious. And so in Chrome right now it has to go through an extension, and the reason is that we have the keys to extensions. If there turns out to be a bad actor extension out there trying to do something like that, we can turn that off immediately from the Chrome side.
When you ask that question, the first example we usually use internally to explain the same question, the answer to the same question is, imagine any random page saying, please click allow to look at pretty kittens. And I bet you there's a huge amount of people here that would press allow and then allow their screen or their desktop to be scraped by evil websites.
For Chrome extensions and apps, there's already a built-in revocation policy, yes.
Yeah. Yes.
On your SDKs for iOS and for Android, how deep are they going to do everything, including browser?
Yeah, so screen scraping for Android, that's obviously a case where it's a little bit of a newly explored territory there. But we think that that's probably something people are going to want to do. Like I said, as mobile sort of overtakes the desktop, being able to share your tablet, makes just as much sense as being able to share your laptop screen. So it's not there yet, but don't be surprised to see it in the future.
Guys,
Yep.
it's time.
It's time.
All right.
So if you got more questions, you'll have to ask the guys. Can you give these guys a big hand?